Good morning friends, let us see about the basic concepts of group theory in this class. Before entering into the group theory, we have to know certain things about the symmetry. So, symmetry, it is a physical property and is quite intimate with the geometry of the molecules. For example, the symmetry will exist in the buildings such as Taj Mahal, etc. Similarly, in some of the birds and animals, the symmetry will be existing. Similarly, in the human body, the symmetry exists, but as far as we are concerned, we will be very particular with the chemical compounds. For example, let us consider water molecule. The molecule of water is an example for symmetry. So, how this symmetry arises? Symmetry is arised when a molecule is cut down into two equal halves. We can have this butterfly as an example. If the butterfly is cutted down into two equal halves in a longitudinal manner, the halves will be equivalent in nature. Similarly, in the molecule of water, if an axis is passed through the oxygen atom, then we will get two equal halves of the molecule. Therefore, we can tell that the water molecule is a symmetrical molecule. So, these symmetry relationships in the molecular structure provides the basis for a mathematical theory called group theory. So, the symmetry will be playing a vital role in predicting the group theory. So, it is also a mathematical theory, and mainly this theory focuses upon some algebraic property. Therefore, it is also called as algebra of geometry. Hence, group theory is also called as algebra of geometry. Next, an important and basic concept, symmetry operation and symmetry elements. So, here symmetry operation is an operation with a restriction or a specified condition. Therefore, the symmetry operation may be either rotation, reflection or inversion. It may be performed either by rotating the molecule or by inverting the molecule or by reflecting the molecule with a plane. So, as far as our definition is concerned, the symmetry operation is an operation with a restriction or specified condition. So, in order to perform the symmetry operation, there should be a condition. So, this condition may be either by, if in case if we are considering this rotation, the condition is it may be rotated to 180 degree, or it may be rotated to 90 degree, or it may be rotated to 360 degree. Similarly, for reflection and inversion. So, if we are doing some rotation operation, that there should be an axis which is responsible for rotating the molecule. Hence, that particular axis, it is also called as a line, is called as symmetry element. So, symmetry element is a geometrical entity, that is, it may be a point, or it may be a line, or it may be a plane. So, here this symmetry element is classified into 5 major categories. One is said to be rotational axis of symmetry. Second one is plane of symmetry, it is represented by the symbol sigma. Improper rotational axis of symmetry, it is represented by Sn. Inversion center or center of symmetry, it is represented by the symbol I, and the identity element, it is represented by E. Here the rotational axis of symmetry, in case if you are considering a water molecule, if an axis is passed through the oxygen atom, with the help of that particular oxygen atom's axis, if we are rotating the molecule, two possibilities are possible. That is, on first rotation we will be having an equivalent configuration, and on the second rotation we will be having another equivalent configuration. So, here this is called as rotational axis of symmetry. Rotational axis of symmetry is also classified into two rotational axes. One is said to be principal rotational axis of symmetry, and other one is secondary rotational axis of symmetry. Next, plane of symmetry. If we are considering a plane which will reflect the molecule, then it is said to be having plane of symmetry. It is classified into three types. One is vertical plane, dihedral plane and horizontal plane. What about this improper rotational axis of symmetry? In improper rotational axis of symmetry, this rotational axis and the plane of symmetry both on combination will be giving us improper rotational axis of symmetry. That is, in rotational axis of symmetry, rotation operation is performed, whereas in the plane of symmetry, reflection operation is performed. Therefore, rotation followed by reflection is said to be improper rotational axis of symmetry. And in case if a compound is having, or if a molecule is having center of symmetry on that particular center point, with the help of that center point, if we invert the molecule, then it is said to be inversion center, and identity element is nothing but doing nothing operation. That is, we should not do any operation, or the molecule should be rotated to 360 degree. So hence either doing nothing or rotating this to 360 degree is said to be identity element. So this is these symmetry operation and symmetry elements are the basic concepts in order to study this particular group theory. Next, what is a group? Normally in this particular classroom, if we are seeing, you are a set of first MSc students. So therefore, you will be arranged likewise, you are arranged with the help of the marks which you are scored in your third BSc chemistry, that is in your BSc chemistry degree. So likewise, molecules are also arranged, similarly elements are also arranged in a arithmetic manner. That is, a group is a collection of elements that are interrelated according to certain rules. There, what I have said earlier, in case if you are called as first MSc chemistry students, there should be certain norms in order to enter into this particular class. It may be you have to complete BSc chemistry degree, you have to get first class mark, you have to come in merit basis. So these are all the norms which are followed in order to admit you into this particular classroom. Similarly, this group, it is also a collection of elements that are interrelated according to certain rules. Okay. So what are all that particular rules? What we have to follow while designating this group? If you are seeing, in case if an element is chosen from a group, we can choose any two elements. If you are choosing the two elements, the product of those two elements in the group and the square of an each element must be an element in the group. That is, in case if you are telling that number 2 is a element from a group. Similarly, if you are considering another one particular thing, that is 3, another element from the group. So in case if you are combining, that is if you are multiplying this 2 and 3, you will be getting 6 as the value. That 6 should be also present inside the group. That is, the 6 should be also an element of that particular group. It is one condition. Similarly, if you are squaring the 2, that is 2 into 2, you will be getting 4. Therefore, 4 should be also present in that particular group. It should be also an element of the group. Similarly, 6 if you are considering, what is that? 3 if you are considering, 3 square is equal to 9. Therefore, 9 should be also present in the group. So it is the condition. Right. In case if you are considering this C2V point group, I will tell you how to arrive the C2V point group in the forthcoming sessions. Now we can consider a C2V point group. Here the elements present in this are E, C2Z, sigma XZ and sigma YZ. Right. This C2V is an abelian group. What do you mean by this abelian group? In case if you are multiplying two integers, what I have told you already, 2 into 3 is equal to 6. Similarly, 3 into 2 is also equal to 6. This condition is said to be an abelian. Right. So here if you are seeing C2Z, if it is multiplied with sigma XZ, we know that C2Z is nothing but it is the rotational operation performed with respect to Z axis. It is said to be C2. It is the molecule should be rotated to 180 degree, and the reflection plane sigma XZ. Suppose if you are performing an operation, if you are considering water molecule, say for example oxygen, similarly here one hydrogen is present, you are performing C2 operation, therefore it will be rotated like this. This hydrogen will be coming this side and this hydrogen will be coming this side. It is arrived now. Now we are performing this another one, that is if you are inserting a plane along this oxygen, what will be happening? This particular hydrogen will be seen like here, and here this hydrogen will be seen, it is present like here. Therefore, you will be getting sigma YZ. So these three are elements present in the group. Similarly, if you are performing the operation sigma